Wow. My project will be to talk today. We're talking about amorphous silicon solar cell. I use this slides outline to make something like plan. I will start from introduction. Let's know what the amorphous silicon solar cell. This devices, this cells can convert light energy coming from the sun directly into electrical energy through photoelectric effects. This figure illustrates to us the different feature between the crystalline silicon and amorphous silicon, and this feature is the homogeneous structure in crystalline and in non-homogeneous in amorphous silicon. Amorphous silicon cells are one of the most environmentally. Actually, this is not the just one feature in this field, but I will talk about the other features in next slides. Friendly photovoltaic, since they don't use any toxic heavy materials such as condom or lead. It's two kinds. The first one, indoor solar cell, thickness 1.1 millim. The second kind, outdoor solar cell, thickness 3.2 millim. The difference between them, 2.1. Outdoor is bigger than indoor. Amorphous silicon cells are solar cells made of amorphous silicon thin films deposited on conductive glass substrate, and I will explain in the next slides why we deposit it on conductive glass. This relation with the temperature. On layer of silicon on an amorphous solar cell can be as thin as 2 micrometer. And the same thing, this figure explained to us the difference about, it was talking about the homogeneous and non-homogeneous structure. And now let's talk about the structure of amorphous silicon solar cell. And this figure explained to us, illustrate to us the important thing, like a black electrode, protective layer, and glass, something like that. Now we will talking about all of them. Two kinds of layers in this structure. The first, ordinary glass, which is the base of the silicon solar cell. The second, which is transport oxide conductive film. Now, let's know what that means. Let's definition together what the efficiency of amorphous solar cell, what talking about, what is the very important. In high volume processes, the efficiency range from 6 to 900%. The efficiency of amorphous silicon solar cells has a theoretical limit of about 1500% unrealized efficiencies. And then this would be the best approach to produce low-cost electricity. Now let's talk about the advantage. This kind has many advantages, and in my opinion has advantage more than disadvantage, because that is very widely in our life and helped us to make our life be easier. Number one, low cost of material and manufacturing process. That is because the first reason is a silicon solar cell can save a lot of silicon metals. The thickness of a silicon solar cell is less than 0.5. But thickness of C silicon solar cell is different. It started from 240 to 270. The metal is silicon which can be supplied in large quantities, and the price is very cheap. And many features like that highlight absorption coefficient, suitable for mass production, wide applications like the figures below, highlight absorption coefficient because, and low dark conductance, it is suitable for the production of 5, good high temperature performance, higher than the standard test temperature of 25 Celsius. Its optimal output power will be produced. The solar cell is much less affected than that of crystalline silicon solar cell. And number 6, good response to low light. And you can see this kind in the inter-variable light range. And like anything in our life has advantage and disadvantage. Now let's talk about the disadvantage: short lifetime and stability problems. The efficiency is much lower than of crystalline silicon. Now the applications of amorphous silicon solar cell, many things like solar toys, lamps, solar key, solar clocks, solar watches, solar collectors, and many things like that, because it's not directly exposed to light. And this figure explained and proved for what I'm talking about. Now, in summary, in my opinion, the advantage is but more than disadvantage